So welcome, everyone. Thank you for coming out bright and early in the morning to see this talk. Appreciate it. And I hope we have some fun today. So as you know, the title of the talk is Body Hacking, right? But I'm going to qualify that a little bit. I hope I won't disappoint too many of you, but I'm going to call it Body Hacking for the Sane, right? Because if you look online about body hacking, you know, people are implanting things and they're injecting things and they're doing all sorts of craziness. So what I want to do today is give you some helpful hacks that you can use when you go out of this class later today. So more practical information. So you heard a little bit about me in the introduction, but I'm going to expand on that a little bit. So I've been in the program in human biology for 20 years now. So I came down to do a postdoctoral fellowship and dug my claws in and never left. So as you know, this is a very nice place to be. So I decided this is where I wanted to spend my time, and I've been here ever since. I'm an exercise physiologist. So what that means is I study how the body adapts to acute and chronic exercise, and then I use exercise as a means to an end. So to make people healthier, to change the trajectory of aging, to improve human performance. And for me, you got a little sense of this in the intro, it's both a profession and a passion. So I like to be outside, doing it, exercising, going into different environments, and really understanding how my body's changing in those different environments, the intricacies behind human physiology. And then I really love sharing that information with people like you, because I think that the more people learn about their bodies, the more interesting it becomes, and the healthier the choices are that they make. So I also enjoy telling stories. And that's a big thing now here at Stanford. So, telling stories. Science communication. So there's a new notation in science communication that students can get to learn how to communicate about science outside of the scientific world to the general population. And that is very important these days, given that science is kind of getting a bad rap. There's a lot of pushback against it. So if you can engage people in science, if you can reach out and talk to them about things that they understand and appreciate, then that can be a powerful message. So one of the stories that I've told in my career, you just heard about. So I taught that online class, Your Body in the World, Adapting to Your Next Big Adventure. Just out of curiosity, are there people in here who have taken it? How many people have taken the class? Okay, so a couple people. So I'm going to show you the teaser for that class for a couple reasons, which I'll explain later. So let's see this. And I traveled all over the country with my TA, experiencing different environments. We filmed it, and then we gave follow-up lectures on the physiology underlying those experiences.
As humans, we exist within a varied and changeable environment. We are the most adaptable animals on Earth. Below your conscious awareness, trillions of cells are communicating to precisely adjust to the stresses experienced daily or during a once-in-a-lifetime extreme adventure. In this class, you will experience different environments through story videos and learn what changes occur in your body at the systemic and cellular level. You will gain a new appreciation for the amazing capacity of your body to adapt and to survive. You will learn practical tips that will enhance your own personal experience and physical performance in extreme environments. Your body is awesome. Welcome to Environmental Physiology.
As you can see, it's exciting, right? There's a little bit of marketing there. But I showed that to you for two reasons. One is that we're redoing the class to make it a self-paced class. So if you're interested in that kind of thing, look in the next month or so on the Stanford sites, and you might be able to join up and learn about your body and the world. And the other thing is I wanted to give you the feeling for what I see in the human body, that I really do believe it's awesome. It's an amazing piece of machinery, and it's worthwhile learning about it and understanding how to drive your own car, so to speak. So that's a little bit about my story. And you have your own stories, right? So I don't know about them personally, but I do know that Part of your story was that you were probably here at Stanford as a student. You may be a spouse or a guest, but you were here at Stanford, and now you're back here in this classroom at Stanford again. So that's a nice story arc. And in between there, you may have gotten one or many jobs, you may have gotten married, you may have kids, you may have grandkids, and you also may have noticed some changes in your body throughout that time. Some of them good, maybe some of them you're not so fond of, and maybe that's what drew you to this class, to see what's happening with aging and things that we can do to slow that aging process. So hopefully part of your story includes physical activity, but if it doesn't, I'm here to tell you it's never too late, so you can start incorporating that into your personal story now. Okay, so why did I call it body hacking? To be perfectly honest, I made a little mistake. So I gave them the title before I started working on the talk. And what this really should be called is biohacking, right? Small change, but a big difference, because body hacking is a little too extreme. Biohacking is defined as follows: to manipulate a biological system to obtain a desired result, and do-it-yourself biology. So we're going to be doing both of that today in this talk. And obviously, I'm an exercise physiologist. We're going to be talking about movement and physical activity. Movement should not be a hack in our lives, but it sort of has become one. And when our great ancestors were the ultimate endurance athletes. There's theorized that we used to hunt by the persistence hunt, where we would actually run down prey. So we would run for hours and hours and hours to the point that the animals would keel over from exhaustion, and then we could walk up to them and bump them on the head and have them for food. Right? Our sweat glands, the way we move, our two legs allow us to run for long periods of time. These days, unfortunately, we can barely run after 3-year-olds, many of us. So we have come a long way the other direction. And part of that is that we've engineered activity out of our lives. So we have escalators and appliances, and we drive everywhere, and we have massive amounts of screen time. So everything's become very convenient, which is very handy, but it means that we don't have exercise in our lives anymore. And it's only getting worse, unfortunately. So just 2 weeks ago, there was this headline in my online feed: online shopping makes people weak because they no longer carry groceries, say physiotherapists. Like, oh, yeah. And then, a week later, Walmart comes out. Walmart puts its eggs in time-saving basket, grocery pickup. That's going to be very popular. I think it's a good move for Walmart for their business model, right? So they pick up all the groceries for people. They have their employees walking up the aisles. You drive by, they throw it in the back of your car, and you're done, right? One more thing, one more way that exercise has been engineered out of our lives. And incidentally, if anyone knows any high-up Walmart executives, I have a great idea that I think they'll love. So if you could hook me up, I'd really appreciate it. So just a little plug there. So we've compartmentalized our exercise into gyms. And I do this too. I go to the gym. But I have to laugh sometimes when I'm sitting there looking at all the people lined up on treadmills and bikes and lifting weights and thinking, why aren't we outside living our lives, doing this as part of our lives? And I had a friend who had this characteristic, who would circle and circle the gym in her car to find a parking place close so she could go onto the treadmill and walk on the treadmill. And the weird thing is I kind of get it. Like, the exercise is there in the gym, and you don't want to park far away, right? But how weird is that? I mean, it doesn't make any sense that we're in that state. So the purpose of my talk today, I hope, is to inform, illustrate, and inspire, and hopefully deliver new information in the form of hacks that can reduce the burden that some feel towards exercise. So just to start off, 85 years old can look really different. So you can look like this gentleman who's in a nursing home and dependent on others for all of his activities of daily living, or you can look like Alma Kent here at 85 running the London Marathon. Now, if I were to ask anyone in this room who they'd rather be at age 85, they'd pick Alma Kent, I suspect. So there are some things that are beyond your control, right? There are some accidents, there's some diseases. But the thing is, there are a lot of things that you can do throughout your lifespan to direct the trajectory of your aging more towards Alma and more away from this person. And one of those things is physical activity. So we call this healthy or successful aging. And if you look in the literature at how aging is depicted, it looks something like this. It's pretty grim, right? You have aging, decrease in endurance and strength and function, and that leads to a decrease in physical activity, and then you have all these increased disease risks and cognitive function impairments, et cetera. So I look at this with great optimism, because right in the center of all of those things is physical activity. So if you flip that arrow, all the other arrows change too. And you have that power, you have that physical activity power to impact the trajectory of your aging in that way. So if you were to put that in a graphical form, it might look something like this, where you could have anything on this axis. It could be cardiovascular function, it could be strength, it could be cognitive function. You have this increase in the early years, you have sort of a plateauing with a slight fall in middle age, and then a more rapid acceleration, and hopefully avoiding this threshold of disability. But with physical activity, a lifetime of physical activity, the curve will look more like this. You'll have higher peaks. You'll still decline a little bit in middle age, but when you decline later on, this slope is a little bit different, and you will end up above this threshold of disability. So you have a compression of comorbidity. You're able to function more effectively in your later years. And even if you haven't exercised your whole life, if you put the curve on, it'll look something like this. So not as much as if you'd exercised your whole life, but definite benefit, definitely ending up above that threshold. So I did sort of a stream of consciousness. I just threw in a bunch of things that I know that exercise affects. A lot of different things. Everything from functional capacity to disease prevention to cognitive function to aging per se. So we have this magic pill. We have it. It can be free. There are very few side effects. So what's the problem? Well, as you know, most people don't do it, right? So 20% of the people in the US, of adults, meet the recommended guidelines for physical activity. And there are lots of reasons for this. The guidelines look something like this. And I've summarized and sort of paraphrased, but American Heart Association, American College of Sports Medicine, they're all similar. And they say basically 150 minutes of moderate intensity exercise per week. The more intense the exercise, the less you need. You have to do resistance and flexibility 2 to 3 times, neuromotor exercise 2 to 3 times. That's a lot of time. That's a lot of time you need to put into this. And most people don't have that or aren't willing to spend it. They've added a few new things to try and make it easier for people. So they've added the fact that you can cut it up into little chunks, so in little 10-minute chunks, even maybe down as short as 5 throughout the day. So walking to your car, walking to lunch, walking upstairs. And also to avoid sedentary behavior, which we'll talk about at the end of the talk, as an independent health risk. All right. Those are the guidelines. And what's even worse is if you look at the data on who does any recreational activity, the numbers are pretty abysmal. So back in '88, about 15% of men and women, if you average that, did no leisure time activity. And now, in 2010, we're up to about 50% of people do no leisure time activity. And the no will become very significant later in the talk. So we have great potential with physical activity. We also have a problem. People aren't doing it. So is there a way to address the major barrier for most people, time, by providing hacks that either optimize time or integrate movement into daily lives? OK. So when I first created this talk, I had little arrows for all sorts of things. I had bones and joints and hearts and brains and everything. And there are things for all those, but we don't nearly have enough time. So I tried to pare it down. So we're going to go through as much as we can of this. We're going to start with the fitness variables, and then we're going to move on to the health variables. All right, so let's start with cardiovascular fitness. So we're going to look at the problem, the opportunity, and the hack. So looking at the problem, I'm going to be very brief here, because the basic message is that cardiovascular fitness goes down with age. So something called VO2 max, which is the gold standard for cardiovascular fitness, because it has elements of ventilation and transport and uptake and use of oxygen. It's linearly related with workload. So the higher VO2 max, the more work you can do. Over time, it goes down in both trained women in this case and untrained women. And you can see there's a huge variability. So this 70-year-old has a VO2 max that's higher than this 20-year-old, right? So there's a lot of variability. They're all going down. This line of the endurance trained ends up higher and above this threshold of disability. Who will notice the fall first? Probably the athletes, because they just can't quite do what they used to do, so they're noticing. These people may not be noticing, but they're heading for a point where they're not going to be able to take care of themselves. They're going to have functional limitations. And it's not just function, it's all-cause mortality. So I know this graph is probably a little hard to see, although the screen is very large, so maybe you can see it. But this is a study by John Myers, just over at the Palo Alto VA, looking at all of the vets who came in during a period of time for stress tests, so how hard they could work, and looked at over 6,000 men. He divided them up on quintiles of physical fitness. So this is the most fit group, the highest group. This is the least fit, and this is the relative risk of death over an average 7-year follow-up. So compared to the fittest group, the least fit group has a 4.5 times higher risk of death in that follow-up period. You can see that there's sort of a swooping line where the biggest drop occurs between these two. And this is both in normal subjects and in subjects with cardiovascular disease. You can also have a similar curve based on the amount of physical activity. So this is a more recent study, just came out a week or so ago. So here is increasing physical activity, and here is that curve. So the more activity you do, the less risk you have of all-cause mortality, and a big drop in that earlier part, right? 15,000 men and women, that one in 39 countries. So the opportunity is it's changeable. So these are survival curves, and we'll look at the women. And the top line here is those people who I'm sorry, let me step back a moment. So in this study, they did 2 tests on people within a 9-year period, and they looked at how they survived after those 2 tests. So in this case, they were fit on both their tests, so the highest survival. In this yellow, they were the low fitness category on both their tests. But look especially at this red line. So this was low on the first test and then fitter on the second test, and the survival curve bumps up. This one started fitter with blue and then got less fit on that test. So you got to keep doing it, right? But you can change that survival curve, so change that trajectory of aging. All right, so this is what you came here for, right? The hack. You already know this stuff, so the hack. All right, so if the time is of the essence, then one hack could be high-intensity interval training. How many people have heard of that in the context of the general public? Okay, well, I'm going to tell you why it's effective. So high-intensity interval training, and this is sprint interval training, this is a subset of this greater category. It's not just for athletes anymore, so it's been around for a long time. Little time, big effects. So Gabala started this craze with a paper that came out of his lab in 2006. Everyone kind of knew it was out there, knew you could increase VO2 max and stuff. But what was pretty amazing, so they had 2 groups that they compared directly. Both groups were biking. One did 30 seconds, as hard as possible, 4 to 6 reps, 3 times per week for a total of 6 sessions. So 15 minutes of total training time, plus the added rest time. The second group did 90 to 120 minutes of cycling at 65% of their maximum capacity, 6 sessions, 4 to 5 hours of training. So this is like a standard endurance training protocol. And the results were that the HIT group, the short training group, had the same or better outcomes with 1/10 the exercise amount, right? So if you don't include the rest there. And this was not just, a little bit off there, but this says time trial performance, mitochondria, glycogen, and buffering. So not just in the high-end exercise, but in markers of endurance, of being able to do exercise for a long time. And that was very new, because you thought you had to do this volume training in order to get endurance adaptations. So there have been a lot of other studies that have come out since then, and they've been trying to shrink and shrink and shrink the amount of time that people have to do to see if they can get the right response. Right? So now, this same group recently came out with a paper. Sorry, the references are cut off. Just came out this last year, and they looked at 12 weeks of endurance training, sedentary young men on a stationary bike. They did moderate intensity continuous training, so that's the MICT group, which is 45 minutes at 70% VO2 peak, and the SIT group, the sprint interval training, was 3 times 20 seconds, all-out sprints with 2 minutes recovery. So that's a total of 1 minute of exercise. And there was 5 minutes of warm-up and cool down. So the total time, if you include the rest sessions in the SIT, or the recovery sessions, it was 50 minutes versus 10 minutes per session. So here's that cardiovascular fitness marker. So this is the continuous exercise, this is the sprint training, this is the control group. You can see it was the same response, right, for a minute of exercise. And the really interesting thing, of course, are the other markers. So these markers of mitochondria. So the energy houses in the cell that provide your energy for everyday life and endurance activity. They increased essentially the same statistically, but if anything, the sprint group was a little bit better. And then insulin sensitivity, a key marker in health as we age and in diabetes, improved also with that SIT. So a powerful response for a minute of exercise per session.
How many sessions per week?
2 sessions per week, sorry. Okay. So what does HIT do? Well, there have been a lot of studies, as I said. And here are some of the adaptations in the training realm. So not surprisingly, a lot of the max adaptations, so increase in VO2 max, buffering, capacity, decreased glycogen use and lactate, which is a good thing. It means there's less disruption of steady state. Fitness endurance, so increased endurance, muscle aerobic enzymes, and mitochondrial biogenesis. And the health also with increased insulin sensitivity, systolic blood pressure, bad cholesterol, mitochondrial repair, and fat oxidation. So a lot of stuff going on in those little bursts of activity. So I like to think of this as a hack because I feel like it's tricking the metabolic pathways. So we know a lot about the metabolic pathways, and it's not important, obviously, to know all these today. But that transition of going from low energy to high energy, where there's this period where your body has to catch up, and then you're really at a high intensity, so your body's never quite comfortable. Those little transitions are tricking this pathway, which is normally activated with long-term endurance training, into thinking it needs to ramp up its energy production. It needs to produce more mitochondria for the next round. And so that starts a cascade of adaptations that are really important. And as we learn more and more about the biochemistry, why not go the next step, right? Why not just take exercise out of the equation? Exercise in a bottle, right? So we have exercise mimetics now out there. About in 2008, so a while ago now, there was a front page article on the New York Times, Couch Mouse to Mr. Mighty by Pills Alone. Right? So what they found was that there's a mimetic, there's something that activates this protein that starts this cascade that goes to here, and you can take it in pill form. So the mice that they had, which were not exercising, increased their endurance significantly relative to the other mice who were not exercising, and they never had to move. So I think this is a disaster because there are so many other things associated with exercise that are beneficial that if people have a pill, it's going to be another excuse not to do it, right? And so far, it's not available and working in humans, but you know, we're making progress. We're learning more and more about this, of what little buttons to push in our cells to get the response that we want. So that is definitely a hack, right? But hopefully one that most people will not use. Okay. So there are many follow-up studies, and the reason I put this up is because it matters less exactly what you do. It's just that transition from low energy to high energy and getting really kind of as hard as you are comfortable doing is important. And it's hit the mainstream. That's why many of you have seen it. There's a lot of websites talking about this, you know, perfect for older adults, and there's this cycle of 20 seconds separated by 90, and for cycling, treadmill, dumbbell, swimming, boxing. That's an unusual one, but I could see it, I guess. And even AARP website suggests that HIIT is good for its members. So, is it doable and is it safe? So the doable question is definitely yes. So the shorter you make the increment, not surprisingly, the more people like it, right? So squeeze it down, people like it, right? And it's turning out that you can use other types of exercise to do this. So a recent study just came out this year from that same lab. They're big on the HIIT studies that use stair climbing. So 2 groups, 3 times 20 seconds, all out continuous stair climbing with 2 minutes recovery, or 3 60 seconds up and down one flight for 2 minutes of recovery. So if you only have one flight, you can go up and down. So, and that was 3 times a week for 6 weeks, and they saw the same improvements that they saw with the cycling protocols, although some of the health parameters weren't evident in that particular study, but I suspect we're going to see a lot more looking at that issue. Is it safe? Yes, it's considered safe. It's been tested in young, old, cardiovascular disease, cardiac rehab, diabetics. Here's one study in cardiac rehab that did have a couple incidents, but not a disproportionate amount from the moderate intensity training. And it's usually deemed that the benefits you get from on your heart is worth the risk associated with it. The intervals allow your heart some recovery time. So by working hard and then resting, your heart gets to recover during that period. So if you are new to it, if you're older, you should check with your physician, and you should ramp it up. So maybe not going for the protocol that's as hard as you can possibly go, and picking something that's easier on the joints like cycling or stair climbing. Something like that would be good. Okay. So what we don't know is the long-term benefits. So all these studies so far have been pretty short, 12 weeks, maybe the longest 16 weeks. So we don't know over time whether it's going to match the endurance training that people get. So hopefully it will. Hopefully it'll be a way for people to at least maintain their fitness throughout their life as time gets shorter and shorter for them, available time. And we will see. I know that there's some long-term study going on right now, but of course the data is not available because they're long-term studies. So we'll see. So the problem, as we know, we lose strength as we age. That's a combination of a loss of muscle fiber size and number. So hypoplasia, and also a decreased speed and shortening, which affects power. So power we use for those activities like getting out of a chair, for walking upstairs, getting out of the way of a bus, things like that. Opportunity, it's pretty clear, right? If we do strength training, we're better off in terms of our strength. So here's the strength training line up here. Here's the untrained. So we start higher, and we end up higher in our later years. And the fall off is less with strength training. So it also impacts longevity. So just like cardiovascular fitness impact longevity, so does strength, especially at the low end. So if you are on the weaker third, then you're more likely to have an all-cause mortality event. And on the upper sides, you get the benefit of longer life and a reduction in risk of all-cause mortality. At lower years, you're trying to maximize your peak. In adult life, you maintain your peak. And in older life, you minimize your losses. So a lot of benefits from weight training, not just increased strength and power, but better functional capacity, higher bone density, insulin sensitivity, systemic inflammation, increased longevity, and better body weight maintenance. So we should be going to the gym. I personally dislike lifting weights. I don't find it very interesting. But as I've gotten older, I've tried to force myself to do it because it's harder and harder to maintain your strength as you age from just normal activities and normal endurance activities and playing tennis and things like that. You really need to get in there and do some resistance exercise, whether it's home, the gym, carrying your groceries, back like this, which I do periodically. So again, the hack is you may not need to lift as much as you think. So the gym, where failure is good, right? So in Silicon Valley, we're all about failure and rebounding. Well, in the gym, too. So this graph shows mixed FSR, so fractional synthetic rate, before exercise and then 4 hours post-exercise in 3 groups. So the first group is lifting weights that are 90% of your maximum capacity, so very heavy weights, to failure. And you get a big jump in synthetic rate here afterwards. The middle group is lifting 30% of your maximum, weight matched, so the same amount of total weight as this. But you can say it didn't go to failure, and so now it's down here. It didn't have the same synthetic rate. But that 30% of your maximum weight lifted to failure gives you very similar values for synthetic rate. So it's not so much how much weight you're lifting, but whether you're lifting it to failure. So failure triggers a series, a cascade in your muscle that leads to muscle hypertrophy. And so the first tip is that lifting to failure is more important than the amount of weight in terms of muscle protein synthesis and muscle size. Now I need to sort of qualify that a little bit, because you need to, if you want to get stronger, you need occasionally to lift heavier weights, because you need to adapt the connective tissue as well. So you don't want your muscles getting bigger and not ever putting that kind of strain on the connective tissue. And also the neurological adaptation, so your brain's ability to signal your legs and your arms to actually to contract all simultaneously, you need to have slightly heavier weights as well. But a chunk of it can be done at that lower weight to failure. And here's the other sort of hack part. If lifting to failure, 1 set may be enough. So traditional lifting has said you need to do 3 sets to failure. But it turns out that if you're actually going to failure, the signaling is very similar between that when you do 1 set and 3 sets, right? So you've already activated the pathway. You don't need to do more. So you can cut down the total time. So if you do compound movements in the gym or wherever, you can cut down to 15 minutes, and the results are priceless. And they've even found that just doing the test that they use in these studies to see if you get stronger can make you stronger, right? So they're, you see in control groups oftentimes they're getting stronger. You're like, oh, well, maybe they're lifting on the side. No, they're actually doing the test that makes them stronger. So there's a whole study that just came out that looks at that very issue. So 38 young, untrained men and women, 8 weeks of chest press and leg extension training, 2 times per week. The hyper group did 4 sets to failure, 8 to 12 reps, 90-second rest. The test group did the test. So they did the 1 repetition max testing only, which involves going in whenever the hyper people went to lift weights and doing the test. So you lift as much as you can. If you can, you add a little more. You lift it again. If you can, you add a little more until you can't lift it anymore. So the maximum movements that they did ever was 5. Right? But it was until they couldn't lift it anymore. So this might be a little hard to see because they're light dots, but this here is individual changes in upper body strength. And here's the test-only group and the hyper group, essentially the same value. Right? If you look at upper body endurance, slightly better, but not significantly better in the hyper group than the test group. And here's the kicker. Here's the hack. This is the difference in the amount of weight that they lifted throughout the whole time. So here is for knee extension dominant, knee extension non-dominant, and then chest press. This is the hyper group, lifted all that weight, and this is the group that just did the test. And yet the results were pretty much the same. So the bottom line for muscle, if you're willing to push yourself to failure, it may not require as much time as you think to improve your strength and fitness. Okay. Fingers crossed that we can move to the health part without the Prezi quitting. All right. So we're going to move into more of sort of the activities of daily living, which some of you may be more interested in, some of you may be less interested in, but it's a nice little balance here. Okay. So for health, how much or how little is enough of exercise? Because most people want to know how little, right? It's a tough question because everyone's different. But I'm going to give you some information, and then we'll sort of work it out. So here are the guidelines that I put up before. And if you're doing these, great. Keep doing them, because there's a lot of data behind these that show that this will help your health and your longevity and make your functional capacity higher. So that's wonderful. But there's this whole group of people who are doing no physical activity, right? So what can we do for them to help? Well, it turns out that if you get those people just a little bit more active, you get a big bump up in health and a decrease in mortality. So here's number of deaths per 10,000 over a follow-up period. Here are men's fitness levels, so quintiles again, and women's. You can see that going from the least active to the next category, you get the biggest jump. And this is a pretty old study. I think it might be 1990 or something like that. But there's been a lot of studies since then that have corroborated this, that have similar values where this biggest jump. In fact, I showed you 2 earlier. And here is that study we looked at earlier, looking at not fitness level, but activity level. And on this scale, it doubles it every time. So 0 to 5 MET hours per week. So a MET hour is sort of the intensity times the amount of time divided by the weeks. So MET hours doubling each time. And here it is on a linear scale. You can see that the drop-off is even more dramatic. So what is a MET hour? Like, what does that even mean? Well, here are some examples of MET hours. So walking for an hour at 3 miles per hour is 3.3. Heavy gardening work 4. Bicycling, swimming, running, etc. So we're talking in this category here. So let's say it's even, if it's the middle of this category, we're talking 1 hour of walking a week. Maybe if we're at 5, it's 1.5 hours, something like that. So you divide that up over the week, 10 minutes a day of brisk walking, and that has that dramatic improvement in health and reduction in all-cause mortality. Yeah, you can swim for, half an hour a week. If you're a runner, turns out you don't actually need that much time running for health again. So these are not going to necessarily make you Olympic athletes or anything, but they're going to make you healthier. So if you're a runner, this is a similar type of thing. There are quintiles of amount of time here. So these correspond with the points above. So they don't run at all. And here we have less than 51 minutes. So, about 8 minutes a day of running, and you get that drop, and then it looks pretty steady after that in terms of all-cause mortality, either for cardiovascular mortality or all-cause mortality. And then it goes up from there. So you get a big bang for your buck at the low end. It's a sort of law of diminishing returns, whether you're talking about fitness or disease risk. So on the fitness curve, athletes that train and train and train hours every day, and they improve, 2% over the year, right? But you get someone off the couch, and they can improve 20, 30% in their first, 3 weeks out. Same thing with disease risk. You get the biggest improvement here. You get a little bit active, and then it kind of stretches out from there. So we should be thinking in terms of public health, not like this, but like this, going out for a brisk walk on the beach. So could life activities help? They probably can. So go back to that original slide I showed you about all the things that make our lives easier. So start thinking in your own life about removing those things from your life. If you, instead of emailing your person in the office down the hall, go and talk to them. Go downstairs to get the printer, get the pages down there on the printer. Walk with your dog, walk with your kids. Some of you, I notice, are noticing this last category here. So I'm not sure if that's a true lifestyle activity, actually maybe a higher intensity activity, but I couldn't resist. I'm sure you can burn a lot of calories in that situation. So again, 5 to 10 minute increments, working them into your day. So the mechanism here is probably using your muscles, right? There's no mystery here. Caloric expenditure or a reduction in sitting time. We have one more category, sitting. So let's go over there. Every time this moves now, I get a little antsy. Okay, sitting, ACK, right? So you've probably seen, could interrupting sitting simply be a hack? So you've seen some of these headlines probably. The perils of sitting, sitting kills, sitting is the new smoking, beware of the chair, right? So they're out there. In fact, I feel a little guilty having you all sitting here watching this. I teach an hour-and-a-half class at Stanford, and always in the middle of the class, I make everyone get up and do some type of movement exercise because I just don't want to be part of the problem. I want to be part of the solution. But we're only an hour, so I think we can make it. You can walk around afterwards. So sitting is this new public health risk, and people are focusing on it. Here's another little icon from the Medical Billing and Coding Organization. So they're on board. It does talk about how, on average, people spend 9.3 hours sitting, 6.5 walking around, and then 0.7 in more vigorous activities. So this is of waking hours. So if you can get that 9.3 hours below 6, there's a big jump in improvement. And there's some statistics on here that I haven't personally validated, but they seem in line with the research out there. Here's an actual study done by Claude Bouchard, looking at the relationship between, again, relative risk for all-cause mortality and the cardiorespiratory fitness, moderate to vigorous physical activity, and sitting. So the sitting here is on the reverse scale. So this is less sitting, and this is more sitting. You can see it holds its own with those other powerful variables. So looking at that, the less sitting that you do, the lower your risk for all-cause mortality. And this is controlled for other variables as well. So what do we know about sitting? Well, it's an independent risk factor for disease. Right? So the more you sit, the more likely you are to have things like abnormally high BMI, abnormal lipids, so it affects fats and glucose, and diabetes, and cardiovascular disease. It's thought that it's not actually the other side of activity, it's its own thing. So when I'm standing here, I'm using my postural muscles to keep me up. My postural muscles are those red muscle groups that burn a lot of lipids you can use throughout the day. They're not your explosive exercising muscles. And that process clears lipids from my system, and it changes a variety of parameters associated with disease. Right? So using them is important. Even sitting on a Swiss ball, for example, would be good because you have to constantly balance yourself, even if you're in the sitting position. The interesting thing is outside activity is only partially protective, and interrupting sitting may help. So I have this watch that I frequently wear. Didn't really go with my outfit, so I didn't wear it today. But I basically wear it around all the time. And sometimes it pisses me off because I will go out and I will go cross-country skiing for 4 hours. I'll come back, I'm exhausted. I come back, I sit down with my lunch for a peaceful moment, and bzz, you know, it starts buzzing at me because I've been sitting for more than an hour. I'm like, come on, you're killing me here. I've just been outside. But the thing is, that watch is pretty smart, right? So it knows that even though I've exercised already, that I really should be getting up every hour. So it's not fully protective. So the watch is smarter than I am sometimes. And it buzzes every hour. So I'm at my desk at work, reminds me to get up, to walk around. And there are studies to show that even if you keep the sitting amount the same between groups, but in one group you have them get up for 2-3 minutes every hour, they're going to be better off than the other group in terms of disease risk profile. So if you do it every 30 minutes, that's even better. So there are many potential targets for this. You know, work, screen time, school, the environment, so changing buildings so that you have to go upstairs, you know, putting printers downstairs, having standing desks in school, all those types of things. There are a lot of public health implications for this that could be very useful. So how much sitting is too much? Everybody asks this question. It's very hard to answer. The best analogy I've heard is it's like the sun and skin cancer. So we know it's bad for you. We know you want to minimize it, but you can't really say, well, if you're exposed this much time, you're going to get skin cancer. Some people may be exposed their whole life and not get it. Some people may be out for short periods of time and get it. So it's a contributing factor, but there's genetics, there's a lot of other things that go into it. But I will show you sort of my interpretation of what it means. So if this is our general mortality curve, right, with the optimal amount of exercise here in the middle, not including our hack of high-intensity interval training, but we have this going on, I would put the sitting line kind of like this, so that it shifts that line up. You're still getting benefit from the moderate exercise, but you're not getting as much benefit as if you'd reduce the sitting time as well. And down at this low end, where people are doing no activity, it's really important to limit the sitting because this space between the two is even bigger. So you add exponentially more to your risk if you don't exercise and you sit a lot. Here, the exercise is partly protective, but you still need to be aware that you need to be getting up periodically. So examples of things that you can do: take all your calls standing up. And you can see that I'm a bit of a pacer, right? I like to walk. I'm surprised I haven't made it all the way across the stage. But I take all my calls standing up, and it's actually gotten much easier since we've gotten cell phones, because I used to be around my office like chained to the desk, you know, walking around like this, and now I can just walk freely with my phone. Take a walk after every meal, no matter how short. While working, set a timer on your phone and take a stroll around the floor or up some stairs every 45 minutes. Get up in between when you're watching TV, in between the commercials, and do something. And if possible, set up and use a standing desk in your office, or even better, a treadmill desk. So I know a lot of people who have convinced their departments that they have to have a standing desk, and then they always have it in the seated position. Doesn't work that way, right? You have to actually use it in the upright position for it to be effective. All right, so let's dive in for some concluding comments right into the belly, because we can, because it's Prezi. So what I've impressed upon you is how powerful physical activity is. I know you've known that all along. You're probably very active yourselves. But there's an expanse of benefits that come with physical activity. And I didn't even get to all the ones about cellular aging and things like that. So I may actually put together an expanded class on this also online, where you can go into all the different categories. So if you're interested in this topic, keep an eye out for that as well. So it's very powerful. There are shortcuts that you can take, and that we're finding that really, if it's on the high intensity level, less and less may be effective for those goals that we're trying to achieve. So just a little side note that it doesn't just affect fitness and health. There are all these things that come with increased physical activity. So if you can get children active very early, it affects their grades and how much they smoke, and then leading to reduced risk for various diseases. And as people get older that are active, they have kids that tend to be more active. So there's this beneficial cycle associated with keeping people active throughout their lifespan. And the last thing I want to leave you with before we get on to questions is just a little snippet of the brain. So here is a brain in a child after exercise, after walking for 20 minutes versus sitting. So you can see that there's a lot more activity. So this is a brain scan going on here. And if you give them a test after that, their academic achievement is higher after that 20 minutes of walking. So you're not children, but this works on you too. So because you're back here in class, I wanted to show this to you. Say there's a powerful effect of exercise on the brain as well, both acutely and in terms of cognitive function. So before you go to your next class, go out and walk around a little bit, and you'll come back prepared to absorb more information when you come back to your next classes without quizzes.